How to Lead a Science Class, a condensed guide to leading a lab. Laboratory classes provide students with first-hand experience with course concepts and with the opportunity to explore methods used by scientists in their discipline. Leading a laboratory session has particular challenges and opportunities that differ from those in a standard classroom environment. Laboratory classes are typically led by graduate student TAs, or teacher assistants. Teachers or teacher assistants need to know and review the experiment, plan clear explanations, and create questions to stimulate student thinking. In addition, it is the responsibility of the teacher to ensure the safety standards are followed. Safety is paramount in a science class. This page contains a variety of resources to help teachers ensure that they and the undergraduate students they teach get the most out of the class. Best practices. Here are some of the best practices to follow that can help laboratory sessions run smoothly. Develop intuition and deepen understanding of the concepts that you're going to be teaching. Apply concepts learned in class to new situations. Experience basic phenomena. So if you haven't done the experiment before, make sure you go over it before you have the lesson so that you're comfortable with it. Develop critical quantitative thinking. Develop experimental and data analysis skills. Learn to use scientific apparatus. When running a lab, learn to estimate statistical errors and recognize systemic errors. Develop reporting skills, written and oral. Practice collaborative problem solving. Exercise curiosity and creativity by designing a procedure to test a hypothesis. Better appreciate the role of experimentation in science and test important laws and rules in your science class. When preparing for a lab, consider the following questions. Will I be able to do the lab myself before class? Or is this a multi-person lab for the experiment? Am I familiar with the materials and equipment? If not, practice using them and go over them beforehand. What are the safety considerations? Review all safety needs and practices before you start the lab. Would it help if I gave my students a handout highlighting key theoretical, procedural, and safety points? If so, make one. How can I link this lab to the professor's lecture? How can I clearly communicate the criteria used in grading lab reports? Preparation continued. What kind of preparation should my students do before they come to lab? What tips can I give my students so they can complete the lab successfully within the time allotted? Try to give the students as many tips as you can before the lab so that they can do it as best they can. Would it be helpful if I demonstrated new techniques to the students? How will I monitor student progress in the lab? Where might my students run into difficulty completing the experiment? If there's a particularly difficult part, try to go over it beforehand with the students so they know what they're getting into and how to get over any difficulty. What kinds of questions should I ask my students to stimulate their thinking, and how to encourage deeper understanding of the experiment? And how can I help lab pairs or groups work together well? During the lab. While running the lab, it's important to establish the specific goals of the lab. Write them on the board for the students to see. Prepare an outline on the board of the lab activities, so step by step what you're going to be doing in the lab for all the students to see. Do not hesitate to explain things more than once or answer questions that you may consider simple. This will likely save you from the headaches later on of answering the same question over and over again. Demonstrate new techniques to the class or small groups. Review safety issues for the lab. Visit with each student individually during the lab. Ask specific questions of the students in order to monitor their progress during the lab. And always provide ample feedback to the students during the lab. Let them know how well they're doing or what things they need to improve upon. After the lab, you have to grade lab reports. So ensure that your grading scheme is consistent with the course policy. Determine whether students understand the lab. Assess whether many students missed a critical concept. Evaluate whether students drew reasonable conclusions from the data they collected. Reward creative and rational but unconventional thought and application of principles. Read, evaluate, and return lab reports in a timely manner with cogent feedback. Help students improve by telling them how they could have done better. And focus comments in specific areas rather than on the report as a whole. So try to be specific. So what makes a good science teacher or lab assistant? In their feedback to TAs or teachers, students indicate that they appreciate lab TAs who summarize the theory and procedure briefly before the students begin the lab. Demonstrate new techniques. It's always important to show the new techniques to students before they've done them for the first time. Relate the lab to the lecture and to real-world applications. Teachers who are willing to help and answer questions are always prized. During the lab, walk around and check with students to make sure that they are making progress. Ask questions that make students think more deeply about what they are doing and why. This will give them a greater understanding of the lab. Lectures. Evidence from a number of disciplines suggests that oral presentations to large groups of passive students contribute very little to real learning, especially in a science class. In physics, standard lectures do not help most students develop conceptual understanding of fundamental processes in electricity and mechanics. Similarly, student grades in a large general chemistry lecture course do not correlate with the lecturing skills and experience of the instructor. Science is a very hands-on subject, so lecturing is not very effective in this field. If you have a very large science class, there are ways to enhance the learning process. Despite the limitations of traditional lectures, many institutions are forced to offer high enrollment introductory science courses. Many professors who teach these courses feel that lecturing is their only option and can only dream of what they could accomplish with a smaller class. However, there is a small but growing group of science faculty members who have developed ways to engage students in the process of thinking, questioning, and problem solving despite the large class size. And strategies in use in introductory courses in biology and geology are described in the sidebars. Large classes continued. Although many of the methods described in these chapters are consistent with what experts know about how students learn, they may not be welcomed by all the students in a class. There are several ways to help students make the transition from passive listeners to active participants in their own learning. If giving a lecture, start off slowly. Students may not have much experience in active learning. Introduce change at the beginning of a course rather than midway through it. Avoid giving students the impression that you are experimenting with them. Students do not appreciate that. The end.